So first of all, here we have a seawater contains approximately 1.2 ounces of salt per liter on average. So let's underline 1.2 ounces of salt per liter. How many gallons, so this is what we want, of seawater to the nearest tenth of a gallon would contain 1 pound of salt? Now this last question is kind of hefty. What is the main idea of this question? We want to find how many gallons are in 1 pound of salt. Better yet, what this means is we want the number of gallons per pound. So this is our goal. So there's multiple ways to solve this problem, but I'm going to use the method we used in class. If this is our goal, let's write this as our goal, gallons per pound. Okay, so that's our goal. Now, if this is my goal, I should always achieve my goal by starting with what I need. So I'm going to start with gallons on top in my first fraction. So I need to look somewhere in my problem or in my reference sheet, which is located in the back of the Regents packet, and see if I can find gallons, pounds, and ounces, all like, or liter related somehow. So if you look at the reference sheet here, I see here there's multiple things that have gallon in it. So we have here 1 gallon is 4 quarts, 1 gallon equals 3.785 liters, and 1 liter equals 0.264 gallons. Now, which one of these do we use? Well, if you notice, we have ounces, liters. So I'm going to use the one with gallons and liters in it. But yet, there's still 2 choices that I got to pick from. Remember, the goal of the problem was to have gallons per pound. So I need a number for gallons, which means the one that you pick is the one that has a number that is not 1 for gallons. So we're going to pick this one. So now let me write down 0.264 gallons goes with 1 liter. Now, just a quick review on what we mentioned in class. In middle school, when you learned about multiplying fractions, you learned that you have to cancel vertically, diagonally, but never horizontally. So right now, so far, we have reached our goal. We want gallon on top. That means every other unit that I don't need has to be canceled. So now we're going to set up the next fraction and make sure that we have liter diagonally. So these end up canceling. So now I need to look anywhere in my problem where it says liter. And if you look over here, per liter. Now remember, per means 1. So I'm going to write 1 liter. So the per liter goes with 1.2 ounces. So let's write 1.2 ounces. So as you can see, diagonally right now, we can cancel the liter and the liter. Remember, my goal was to get gallons on top and pounds on the bottom. Here we have ounce. So there has to be another fraction that we're going to set up so that diagonally the ounces are going to cancel. Now, is there anything here that tells me more information about ounces? No. So then we're going to look at the reference sheet. So anything with ounces, well, here I have 1 pound equals 16 ounces. So I'm going to use that to my benefit. So I have 16 ounces goes with 1 pound. Now notice here, now we're getting closer to our goal. We have pound on the bottom. So what happens to these ounces diagonally? We're going to cancel them. So cancel. And so now we have everything on top. The only unit that's left is gallons. And everything on the bottom, the only unit that's left is pound. That's our goal. Now all we're going to do is now put this in the calculator. And so we're going to multiply 0.264 times 1 times 16. And when I put that in the calculator, I get 4.224. Now on the bottom, we have 1 times 1.2 times 1, which is 1.2. I'm still not done with the problem. I'm going to simplify this fraction. So 4.224 divided by 1.2. When I put that in a calculator, I get 3.52. Now remember, the goal was gallons per pound, but going back to the question, it says nearest tenth. This is the decimal point. This is the tenths place. You look at the next door neighbor. The next door neighbor is not 5 or more, so this stays as 3.5 gallons per pound, which is multiple choice 2.